Hello dear students, in this class we are going to discuss few miscellaneous problems related to definite integration. Let's see one question. Let denotes the greater integer function, this brackets. So integration 0 to e to the power of 3 step function of 1 by e to the power of x minus 1 dx. Now here the function here he given 1 by e to the power of x minus 1 inside that. So here function is 1 by exponential, right? First of all we will understand what is here y is equals to e to the power of x graph. Okay, so this is increasing function, this will move in this way. Okay, this is a 1 unit which is 0 comma 1. Okay, next if I write here y is equals to here in the function 1 by e to the power of x is there, so I'll write 1 by e to the power of x graph is this way. This will decreases in this way. Okay, this is decreasing in this way. So this point is 0 comma 1. Now see here decreasing function, if I give input 1, corresponding value is certain value, let us say. If I give input 2, that result is corresponding y value is less comparing to the 1. Okay, if I give input 3, output I'll get less than that. If I give input 4, I'll get less than that. That means if I keep on giving inputs, I'm getting outputs is reducing. That means it is approaching towards 0. Now let's draw the graph of this function. Okay, what is the function inside is given? Function f of x is equals to 1 by e to the power of x minus 1 is given. So here we will write here 1 by e to the power of x into e to the power of minus 1, and e to the power of minus 1 goes to numerator, e to the power of 1 by e to the power of x. So we have to plot this graph. This is a function. Okay, this is a function. So I'm plotting the graph. Using graph we'll solve this problem. Okay, so this is let us consider this is x-axis and y-axis. So in denominator e to the power of x is there, therefore this is decreasing function. Let us consider input x is equals 0, substitute. If I give input x is equals 0, what I'll get? Output is I'll get e. Okay, since we know that reducing means decreasing function, so this is like decreasing function, never touches x-axis but it will keep on moving, asymptote kind of thing. Okay, now so if I give done, if function value, actually if I give input 0, what I'll get? E. That means e what is the value of e value is 2.732 something. Okay, so this is 2.732. here function of greater integer means here the graph will breaks at integers. Okay, graph breaks at integers. So for e is 2.73, so 0 we have, so 0 to e, how many integers we have here? 1 and 2, right? This is 1 and this is 2. So we will check now. Let us consider function itself. E by e to the power of x is itself, output is 2. The entire result is output 2. So if output 2, what is the input is what? We will check now. Okay, if I substitute, apply log on both sides, log e to the power of plus x goes to the numerator, minus x, 1 minus x is equals to log 2. Base e, here we are using base e log. Log e base e is 1 minus x, which is 1 minus x. This is log 2 base e. Now if I send here minus x to this side and to this term, x is equals to 1 minus log 2. So here the breaking, that means here at you are getting 2 result at x is equals to you are getting 1 minus log 2. At x is equals to 1 minus log 2. And next, let us say the function value is 1, because at 1 is also it is breaking, right? At integers only greater integer function breaks. So 1. Then at what value of input you will get output 1. So at x is equals to 1, e cancel, you will get output is 1, right? So x is equals to 1. At x is equals to 1, output is 1, input is 1. At what value of input, output you are getting 2. That means input is this, you are getting 2. Clear? In the same way, so we got here 1, and in the x limits are from where to where it is given. X limits are 0 to e to the power of 3. Yeah, limits are 0 to e to the power of 3 is given. So 0 to e to the power of 3. Therefore here we will consider 0 to e to the power of 3, right? 0 to e to the power of 3. E to the power of 3 means 2.732 and so on, right? So the input is e to the power of 3, then output is definitely lies from 0 to 1, right? This output is lies from 0 to 1, because already integers are 1, 2. In between them 0 to 1 only, e to the power of 3 output will lies. Okay, now let's see a step function. So I'm breaking the function 0 limits. I'm breaking the limits 0 to e to the power of 3. E to the power of 3. E to the power of 3. What is the function? E by e to the power of x, step x dx. So from where to where I'm breaking the x limits are, so 0 to 1 minus log 2 e by e to the power of x dx plus, so 1 minus log 2 to 1. I'm considering 1 minus log 2 to 1 limit. Greater integer function of e by e to the power of x dx plus integration 1 to here the result 1 to e to the power of 3, 1 to e to the power of 3, 1 to e to the power of 3 step e by ex dx. So from this what you understanding? So 0 to 1 minus log 2 I am getting result 2, right? If I give input 0 I am getting e. So e to 2, if I do step function, what I'll get? 2 only I'll get, right? 2 to 2.73. Then step function is always 2 only. This result is 2. Okay, this result is 2. And then so 1 minus log 2 to 1. 1 minus log 2 to 1. The greater integer, so greater integer from 2 to 1. 2 to 1 is what? 1 only, right? So this result is 1. And so e to the power of input is, e to the power of 3 input is this, output is what? Lies from 0 to 1. Lies from 0 to 1. So if I consider greater integer function of 0 to 1, I'll get always 0. So this result is 0. This result is 0. Okay. So integration of 2 dx. 2 dx is x. From where to where the limits are? 0 to 1 minus log 2 plus integration of 1 dx is x, where the limits are 1 minus log 2. Lower limit is 1 minus log 2, upper limit is 1. This is 0 into something is 0, no need of writing. So 2 times of upper limit substitute, 1 minus log 2, lower limit is minus 0 plus upper limit is 1 minus lower limit is 1 minus log 2. Okay, so 2 into 1 2 minus 2 log 2 plus 1 minus into 1 minus 1 minus 2 minus plus log 2. So 2 plus 1 minus 1 cancel, 2 minus 2 log 2 plus log 2 minus log 2. So what is given actually the question? Your question is given alpha minus log 2. Okay, here the I is a question, result is given alpha minus log 2. Okay, from comparison we can say alpha is equals to 2. Is asking alpha cube. Alpha cube is 8 cube. Sorry, 2 cube is 8. Therefore 8 is the right answer. 8 is the right answer. Next question. In this, the value of 9 times of 0 to 9 step function of root over 10x by x plus 1 dx, where this is a greater integer function less than t. Okay, so here we have greater integer function we have to integrate. Okay, so first of all given question is 9 times of, right, 9 times of 0 to 9 greater integer of root over 10x divided by x plus 1 whole dx. So 0 to 9 is the x limits. 0 to 9 is the x limits. Okay, 0 to 9. So here the function value will breaks at integer, right? Function value breaks at integer. Now let us consider here x is equals to 0. At what value of 0 first? 0. Okay, fine. 0 after 1 I'll get. After 1, 2 I'll get. 3, 4, 5 and so on. So let us say this is a function. I'm considering this inside function. 10x divided by x plus 1. Let us say this value, entire value, range value is, the entire value is 1. Let us consider. This is 1. Output is 1. Output is 1. At what value of input? We have to find. Input is x. Okay, we have to find input now. Okay, let us consider squaring on both sides. Squaring on both sides. 10x divided by x plus 1 is equals to 1. And from here, 10x is equals x plus 1. X send it to here. 9x is equals to 1. X is equals to 1 by 9. So at input of 1 by 9, output is 1 I'm getting. Okay, let us consider this value result is 2. Okay, the same 10x divided by x plus 1 result is, let us say 2. Okay, 2. Let us say 2. After 1, 2. Output is 2. At what value of input I am getting that 2? We will check now. Squaring on both sides. 10x divided by x plus 1 is equals to 4. And the result here is 10x is equals to 4 into x, 4x. 4 into 1, 4. So 4x send it to left side, 6x is equals to 4. So here x is equals to 2 3s, 2 2s. 2 by 3. Okay, this is 2 by 3. At input of x is equals 2 by 3, I am getting output 2. That means step function breaking at 2. Step function breaking at 1. Next is step function breaking at 3 also it will breaks. Now let's check it out. At what value of input it is breaking. Okay, so this is 3. Range is 3. I mean y output value is 3. At what value of input it is breaking. We'll check now. So squaring on both sides. 10x divided by x plus 1 is equals to 3 3 is a 9. So when I'll get 9 here, if I substitute 1, input x is equals to 1 if I give, or else simplification, simple. 10x is equals to 9x plus 9. So 9x, send it to left side. 10x minus 9x is x is equals to 9. Input of 9, I am getting output is 3. That means greater integer function breaking at 3. Greater integer function is breaking at 3. Now we have to write the limits. Here limits are, x limits are 0 to 9 is given actually. X limits are given 0 to 9. That means here 0 to 1 by 9 it is breaking, and 1 by 9 to 2 by 3 it's breaking, and 2 by 3 to 9 it is breaking. At 9 it is breaking. So at initially started with limits are from where to where? 0 to 9. Step function of root over 10x by x plus 1 dx. So I am breaking the limits, x limits, okay, x values 0 to 1 by 9. 0 to 1 by 9. Step function of root over 10x divided by x plus 1 dx. Okay, plus 0 to 1 by 9. 1 by 9 to 2 by 3. 1 by 9 to 2 by 3 greater than the function of 10x divided by x plus 1 dx. 2 by 3 to 9. 2 by 3 to 9 greater than the function of 10x by x plus 1 dx. So this is what we have here. Now we have to check the result. So 0 to 1 by 2, 0 to 1 by 2, 0 to 1 by 2 result is actually at x is equals to 1 by 9 it is 1. Range value is 1, output value is 1. That means below to this 1 by 9 is 0, right? Less than 1 by 9 is 0 only, right? At 0 definitely less than 1 only I'll get, right? At x is equals to 1 by 9 I'm getting 1, but less than 1 by 9 is 0. If x's input is 0, output definitely less than 1. Less than 1. That means if input greater integer function of less than 1 is always 0, right? This result is 0. So 0 to 1 by 9, 0 dx plus 1 by 9 to 2 by 3. 1 by 9 to 2 by 3. See here, at 1 by 9 I'm getting 1. At 2 by 3 I'm getting 2. So 1 by 9 to 2 by 3, range values lies from 1 to 2, right? Step greater integer function of 1 to 2. If I do, what is the result? I'll get 1. Okay, in between 1 to 2, if I do step function, I'll get 1. Okay, 1 left side value I'll get. So this is 1 dx plus integration 2 by 3 to 9. 2 by 3 to 9. So here 2 by 3 to 9. 2 by 3 to 9. Input 2 by 3 to 9. Here 2 by 3 corresponding output is 2. Here output is 3. So 2 to 3, if I do greater integer function, if I do 2 to 3 greater integer function, I'll get 2 answer. Okay, so I'm writing here 2 dx. Now we have to integrate. This result is 0, therefore integration of 1 is x. From where to where? 1 by 9 to 2 by 3. Plus integration of 1 is x. From where to where the limits are? 2 by 3 to 9. Now we will apply the limits. Upper limit 2 by 3 minus lower limit 1 by 9 plus 2 into upper limit is 9, lower limit is 2 by 3. So 2 by 3 minus 1 by 9 plus 2 9s are 18 minus 2 into 2 4 by 3. 2 minus 4 by 3 is minus 2 by 3, right? 18 minus 1 by 9 plus minus 2 by 3. So I need LCM 9 9. So first I'll 3 multiply on both sides. 3 2s are 6. 2 in order to make it LCM. Minus 1 by 9 minus 3 2s are 6 by 9. Minus 1 by 9 minus 6 by 9 is minus 7 by 9. 18 minus 7 by 9. So this is 18 minus 7 by 9 answer. Okay, so yes, 9 is multiple is there actually. So 9 times of result we need to find. Okay, 9 times of result we need to find. So this is the result I. Then what is asking? 9 times of I is asking. 9 times of 18 minus 7 by 9. If I multiply 18 to 9 into 18 minus 7, 9 cancel. If I do simplification, what I'll get here? 162 minus 7. Okay, from here I'll get 155. Answer is 155 is the right answer. That's all. This is the answer. Here we have another question. Let the denotes a greater integer function. So 0 to 2.4 integration from 0 to 2.4 greatest integer function of x square dx. So here input is 0, output is input is 0 to 2.4. That means limits are 0 to 2.4 means input is 0. If input is 0, output is also 0. No, right? Let us consider at output. We will consider 1. Okay, output will consider 1. At what value of input I'll get 1? We will check now. Okay, x square is equals to 1. X is equals to root 1, which is 1. So therefore in output I'm getting 1 at input of x is equals to 1. Okay, that means at 1 and 1 comma 1 the function is breaking. Now let us consider output. Okay, output I'm getting, let us say 2. At what value of x I'm getting input? 2. Output 2. Okay, x square is equals to 2. So x is equals to root 2. X is equals to root 2. Next x is equals to 1. Now x square is equals to output, let us say 3. Then x square is equals to 3. X is equals to root 3, right? At input of x is equals to root 3, I am getting output is 3. That means the function is breaking at 3, right? Function is breaking at 3, root 3 comma 3, right? Next, x square is equals to, let us say 4. Then output is I am considering 4. Then at what value of x it is getting 4? We'll see. X square is equals to 4. X is equals to 2. At x is equals to 2, output is 4. Next, x square is equals to 5. X square is equals to 5. X is equals to root 5. Here input is root 5, output is 4, 5. Input is root 5, output is 5. This is nearly equals to 2 point something, 2.23 or something. Okay, 2.23 something. Okay, now here actual limit is, x limits are from where to where? 2.4 actually, 2.4. So 6 won't come. Okay, 6 won't come because here 6 is 2.66, root 6 is 2.44, I guess 2.44, but here we have 2.40. So we'll consider till there only. We'll consider till there only. Okay, x square step function is, let us say, 6 value. Then at what value of input I'll get root 6, right? X square is equals to 6. If I remove the step function, x square is equals to 6. Then x is equals to root 6, right? Root 6. So root 6. So root 6 is nearly 2.44. Okay, 44. But we have 2.40 we have. So we will consider for time being. See, let's see now. I'm breaking the limits. From where to where the limits are breaking? So limits are breaking from 0 to 2.4. Function is what? Step of x square dx. We can write it as this. So 0 to 1 dx plus 1 to root 2, right? This is 2, this is 5. Okay, this is 5. Now 0 to 1 dx, 1 to root 2 dx plus root 2 to root 3 dx plus 2 to root 3 to 2 dx plus integration root 3 done, root 3 to 2 to root 5, 2 to root 5, root 5, next root 5 to root 5 to 2.4, 2 point exactly 4, not 4, 2.4. Okay, so here 0 to 1, exactly 1. Okay, at x is equals to 1, input x is equals to 1, we are getting output is 1. That means if input is less than 1, output is will also correspondingly less than 1. If I do step function of less than 1, what I'll get? 0. I'll get 0. So this is 0. Clear? 1 to root 2. So 1 to root 2, output value is 1 to 2. If I do output value step function, I'll get 1 to 2. In between 1 to 2, if I do step function, what I'll get? 1 I'll get. So I'm writing here 1. Okay, this is 1. Next, root 2 to root 3. Root 2 to root 3 is root 2 to root 3. What is the range values of this? 2 to 3. 2 to 3, if I do step function of 2 to 3, what I'll get? 2. In between 2 to 3, if I do anything step function, 2 step function is 2, 2.1 step function is 2, 2.9 step function is also 2. So in between 2 to 3, 2 is the value if I do step function. So this is 2. Next, root 3 to 2. Where is root 3 to 2? Function is what? Function is 3 to 4. Okay, so step function of 3 to 4 is 3. So this is 3. Next, step function of 2 to root 5 is 2 to root 5. 2 to root 5. This is the value, right? So step function of 4 to 5 is 4. 4 to 5 is 4. 4 to 5 is 4. Next, step function of 5 to 6 is 5. 5 to 6 is 5. Therefore 5 dx. Now we have to integrate these results. You will get the answers. Now let's see. 0 integration is 1 integration is x, from where to where the limits are 1 to root 2. Okay, so 2 integration of x is, integration 1 is just x, root 2 to root 3 plus 3 root x, root 3 to 2 plus 4 integration of 1 dx is x, from where to where the limits 2 to root 5 plus 5. Integration of 1 is x. From where to where the limits are? Root 5 to 2.4. 2.4. Okay. So here upper limit root 2 minus 1 plus 2 into upper limit root 3 minus root 2 plus 3 into upper limit 2 minus lower limit is root 3 plus 4 into upper limit root 5 minus lower limit is 2 plus 5 into upper limit 2.4 minus lower limit is root 5. So from this if I solve this problem, so root 2 minus 1 plus 2 into root 2, 2 into root 3, root 2 root 3 minus 2 root 2 plus 3 2 is 6 minus 3 root 3 plus 4 root 5, 4 2 is 8 plus 5 into 2.4, 5 4 is 20, 5 2 is 10, 12. So 12. Okay. So 12 minus 5 into root 5, 5 root 5. Now I'll write all the values together now. So here is root 2. First I'll write okay, root 2 minus 2 root 2 is minus root 2. Next root 3. Now root the values. 2 root 3 minus 3 root 3 is minus root 3. Next 4 root 5. Yeah, 4 root 5. This is 4 root 5. Next minus 5 root 5. Minus 5 root 5. And the constants are minus 1 plus 6. Minus 1 plus 6 is minus 1 plus 6 is minus 1 plus 6 is plus 5, plus 5 minus 8 is minus 3, minus 3 plus 12 is 9. So this is 9. Okay, 9 minus root 2 minus root 3 plus 4 root 5 minus 5 root 5. So what, this is the result actually, but what is given we will see once. Okay, so here given alpha plus beta times of root 2 plus gamma times of root 3 plus delta times of root 5. So alpha, beta, gamma. So the result, the obtained result is given that alpha plus beta into root 2 plus gamma into root 3 plus alpha, beta, gamma, delta into root 5. Right, delta into root 5. Here 4 root 5 minus 5 root 5 is minus root 5. Right, this result is minus root 5. So from here alpha, comparing, alpha is equals to 9, beta is equals to minus 1, gamma is equals to minus 1, delta is equals to minus 1. If I sum it up, this alpha plus beta plus gamma plus delta, 9 minus 3 is 6. 6 is the right answer. Numerical type, that's it. Here we have a question. 24 into integration 0 to pi by 4. This is not step function. Okay, this is a bracket. This is a bracket. Now here given is 24 into 0 to pi by 4 sine of mod 4x minus pi by 12 plus greater integer function of 2 sin x whole dx. Okay, we have to solve this. So here we have first we will consider this entire only question, not 24 times of. Okay, let us consider this is 24 I. This entire question is I. Okay, so I is equals to integration 0 to pi by 4 sine mod 4x minus pi by 12 dx plus 0 to pi by 4 greater than a function of 2 sin x dx. So first we will consider modulus function. Okay, first I'll consider modulus function. I1 I'll consider this. Okay, 0 to pi by 4 sine of mod 4x minus pi by 12 whole dx. So in order to solve the modulus function, 0 to pi by 4 is the limit we have. So x limits are 0 to pi by 4. Okay, x limits we have to break. Where we have to break? Now inside modulus, make it equals to 0. Okay, 4x minus pi by 12 equals to 0. So x is equals to pi by 48. Okay, pi by 48 I am getting for at x is equals to pi by 48. I am breaking the limit. Okay, so now here inside modulus, try to make it greater than or equals to 0. Okay, try to make it greater than or equals to 0. That means here x is greater than or equals to pi by 48, right? Pi by 12, send it to right side, pi by 12, 4 send it to right side, pi by 48. That means x greater than or equals to pi by 8 I am getting, right? X greater than or equals to pi by 8. So here the function value is 0 to pi by 4, pi by 48 is negative actually, right? If we consider pi by 48, if we substitute in the place of x, pi by 4 times of pi by 48 minus pi by 12 is negative, so it will opens with negative. Okay, if modulus of negative opens with negative, modulus of negative opens with negative of the brackets, modulus of positive opens with positive of brackets. Okay, so now here limits we broke from where to where? 0 to pi by 48 sine of mod 4x minus pi by 12 dx plus integration pi by 48 to pi by 4 sine of mod 4x minus pi by 12 mod dx. Okay, so here inside 0 to pi by 48, if you consider any number, substitute, you will get negative. Inside you will get negative. So what I'll do here, I'll make it opens with negative, sine of, if I opens with negative multiply inside, I'll get first pi by 12 and then minus 48 4x minus 4x dx plus, it will opens with positive, pi by 48 to pi by 4 sine of opens with positive 4x minus pi by 12 dx. Now we know integration of sine is what? Integration of sine is minus cos. Integration of sine is minus cos pi by 12 minus 4x from where to where the limits are from 0 to pi by 4 plus integration of cos sine is minus cos x divided by x coefficient what we have? Minus 4. X coefficient minus 4. Next, minus cos of 4x minus pi by 12 divided by x coefficient what we have? 4 we have. From where to where the limits are from? Pi by 48 to pi by 4. If I substitute the limits here, 4 common out. Okay, 4 common out. And okay, 1 by 4 taking out. So if I take 1 by 4 out, from both sides, minus is there, minus I am writing outside. So upper limit substitute in the place of x, substitute pi, so pi by 12 minus 4x. Here denominator minus there, minus into minus plus I'll get. Okay, plus. So here cos of pi by 12 minus upper limit here pi. This is upper limit minus lower limit is substitute 0. So what I'll get? Lower limit is, so cos of pi by 12, cos of pi by 12 lower limit divided by 4 already there, minus plus I'll get. Okay, upper limit pi by 4, so 4 cancel, pi by 12 minus 4 minus 5 divided by minus lower limit is 0, substitute in the place of x 0, pi by 12 cos pi by 12, done. Upper limit minus lower limit. Next, upper limit minus lower limit, minus is there, right? Minus I'll write, plus into minus, minus bracket open. So upper limit minus lower limit done, plus is there, plus into minus, minus. Next, upper limit substitute in the place of x, cos 4 cancel, cos of pi minus pi by 12, and next minus lower limit pi cancel, I'll get cos 0. Okay, cos 0, pi by 48 multiply here in the place of x, substitute pi by 48, Pi by 12 minus pi by 12 0. Cos 0. So cos 0. So from this 1 by 4. So cos of pi by 12 minus pi. 180 minus theta. 180 minus the minus cos. Minus cos pi by 12. Okay. See here. This is cos of minus theta. Cos of pi by 2 minus pi can be written as cos of pi minus pi by 12, because minus theta lies in fourth quadrant positive. So cos of minus theta is cos theta. We can write this as, so minus cos of pi by 12 is the answer. Minus cos of pi by 12, and this is minus cos pi by 12 minus, and this is minus of minus plus. This is minus minus of minus plus cos pi by 12, and then minus of minus plus 1. So this is the here this limits is pi by 48, right? Pi by 48. Substitute in the place of x pi by 48. This is pi by 48. So pi by 48, if I substitute pi by 12, this is right. Pi by 12 minus pi by 12 is cos 0. This is cos 0. Cos 0. Cos 0 is upper limit cos 0 minus 1. So this is plus 1 actually, right? This is plus 1. Why I'm writing minus here? So here cos 0 is plus 1. Okay, cos 0 is plus 1 here, and then plus 1 here, minus cos to cancel. Here we will get 1 by 4. Here cos 0 is 1 plus 1. 1 plus 1 is 2. Therefore this is 1 by 2. This is 1 by 2 I'm getting. Okay, I'm getting this is 1 by 2. And next is yeah, integration of 0 to, okay, next is I2. 0 to pi by 4 greater integer function of 2 sin x. Okay, using graph we will find. It is easy using graph. Okay, now let us try to plot a graph. If in the place of x is equals 0, 0. In the place of, if I substitute x is equals to pi by 2, x is equals to pi by 2, what I'll get? X is equals to pi by 2, I'll get 1. Answer is 2. So at 2, this is the 2, this is the point. Okay, this is 2. At x place x is equals to let us say pi sin x is 2 I'm getting. So at pi by 4 I'm getting 1 by root 2, which is root 2. Pi by 3 I'm getting, pi by 6 what I'm getting? Pi by 6. So 60 30. So 30 and 30, sin 30 1 by 2, 2 to cancel, 1 I'm getting. So I'm getting the result is 1 here. This is the 1. Okay, so this is the graph actually. So this way it will goes 0 to pi by 2. Okay, we want actually 0 to pi by 4 actually, right? This is pi by 4. The graph goes in this way. Okay, substitute pi 0 it will become, no worries. So at pi it is 0. So here at pi I'm getting 1 is the result. At pi by 4 I'm getting the result is root 2. Root 2 is 1.414 amma. 1.414. So I am getting here 0 to pi by 6. If I consider 0, the limits are 0 to pi. So I am breaking the limits from where to where the limits are 0 to pi by 6 dx plus pi by 6 to pi by 4 dx plus, I am just moving this graph to one side safely. Yeah. Next is 0 to pi by 6 to pi by 4 only we want, right? Yeah, pi by 4 only. So the 0 to pi by 6, if I consider corresponding y value is 0 to 1. If I do step function of 0 to 1, what I'll get? 0 I'll get. And pi by 6 to pi by 4, if I do step function 0 to pi, or else inside 0 to pi by 6 to pi by 4, if I do step function 1 to 1.4, I'll get step function is 1, right? So 0 is 0. So integration 1 is x, from where to where the limits are pi by 6 to pi by 4. Therefore upper limit is pi by 4 minus lower limit is pi by 6. So this result is pi by 4 minus pi by 6. So LCM is 12. 4 3s are 12. 3 into pi 3 pi minus 2 6 are 6 2s are 12. 2 times 2 pi. So therefore 3 pi minus 2 pi is pi. Pi by 12. Here pi by 12 is the I2 result. So overall result is I1 is we are getting 1 by 2. I2 is we are getting pi by 12. So I is equals to I1 plus I2. I1 plus I2, I is equals to we are getting I1 is 1 by 2, I2 is pi by 12. But what we want actually result is asking in the question 24 times of I. Okay, 24 times of I. So 24 times of I. So 24 into I is equals to, if I multiply 24 inside 1 by 2 plus pi by 12, what I'll get 2 times 2 ones 2 twos plus, and 24 12 twos 24 2 pi. 12 plus 2 pi I'm getting answer, but option is given here 2 pi plus alpha is given, 2 pi plus alpha. So we have equate with 2 pi plus alpha, 2 pi plus alpha, 2 pi plus alpha, 2 pi same, alpha is equals to 12. Alpha is equals to 12 is the right answer. So this is 2025 question actually, recent year question. So very important, based on modulus function, greater integer function. That's all. This is the right answer.